Applications of linear equations. So in this video lecture, our objective is to use linear equations to solve problems. Let's start off by reminding ourselves what we already know that's going to be applicable in this video lecture. We know two things. The first is we know what a linear equation in one variable is. It's an equation that can be written in the form ax plus b equals 0, where a and b are real numbers and a is not equal to 0. In other words, you got to have a number here so that your x term exists, because you need an x term in order to have a linear equation. Okay? And the second thing we know, we learned in a previous video lecture, is the steps for solving a linear equation. And there were four. We simplify, then we separate, then we solve, and then we check. And of course, each of these is as necessary. The equation may already be simplified, in which case you would skip this step. Once you simplify, it may already be separated, in which you skip this step, in which case you skip this step, and so on and so on. All right, so what is our strategy for solving these word problems? Okay, well, our strategy is as follows. I hope I'm straight here. Okay. The first step, we want to write down exactly, and we want to include units as necessary, what we're being asked to find. This is a big deal. Most people will try to solve problems without fully recognizing what it is they're being asked to find. And if you don't know what you're looking for, chances are pretty good you're not going to find it. So that's a key step that I find a lot of people struggle with. Step 2 is pretty straightforward. Let x, or any variable, we'll use x, represent this unknown. Step 3 is the most difficult step for most people. Translate the English into math so that you can write an equation in x that models the problem. And I'll be honest, well, I'm going to do 4 examples in this video lecture, but there's no way to do all the examples so that you can see every possibility, because there are an infinite number of those. So you just have to kind of do these, get used to them, think a bit about them, wrestle with them. As you work to translate what they are, it can take some additional thinking, maybe a little frustration at times, but that's really the art of doing it, is this step 3 right here. And then step 4, we're going to solve, as we see right here. Once we have the equation, we're going to solve it right here. Okay? So as I said, I'm going to do 4 examples and just give you a sense of some possibilities as to how things look. All right, example 1 here. Let me see if there we go. So I'll try to get this. I'm trying to keep myself straight here for y'all. All right, example 1. 6 less than twice a number is equal to 4 times the number. What is the number? Okay, step 1. Write down exactly what you're looking for. We don't have any units to this, and I'll put a little 1 down here. Okay, this is step 1. We are looking for the number. Yep, that's what we're looking for. There are no units to it. That's what we're looking for. What is the number? Step 2, assign our unknown the variable x. X equals the number. No problem. So far, so good. Step 3, let's do some translation. This is obviously lots of English, and we need to translate this English into a math equation that models what it is we have here. I like to start off looking for the equal sign. Is equal to is the phrase that is our equal sign. And that's what's going to separate our equation into 2 parts. What comes before that will go on the left, and what comes after that will go on the right. Now let's look at the left. So again, here's step 3. On the left, 6 less than. Well, less than means subtraction. The word than is a switch word. Important to know that. The word than is a switch word, which means what comes in front of the subtraction sign in English goes behind the subtraction sign in math because the word than is a switch word. Twice a number means it's multiplication. Twice is 2 times. So let's take a look. We broke the English down into some math symbols here. 6 less than twice a number. Again, that word than, switch word. What's in front of the minus than, the less than, goes in back of the sign. Is equal to, there's our equal sign. 4 times the number, well, times, of course, means multiplication. 4 times the number, 4x. 6 less than, twice a number, x equals a number, is equal to 4 times the number. Once you've done that, that's step 3. Now we're into solve the equation. And if I move it up here, we know simplify, separate, solve. Check. Okay, I'm going to come back, make sure I'm somewhat straight, I hope. Okay, so let's see here. There's left side simplified, right side simplified. Step 1 is not necessary. Step 2, separate. Well, I have an x term on the left and an x term on the right. My constant term, or my number term, is only on the left. So let's move my variable terms over to the right side of this. Just do one move. That's a 0. Left side is a -6. Right side, 4x minus 2x is 2x. And now I can solve. This is 2 times x, so I want to divide both sides by 2 because the solving means what does 1x equal? Divide both sides by 2. -6 divided by 2 is -3. So there you have it. That's step 3. We translated it. And then step 4, I forgot the number here, sorry about that. We want to solve it, and we've done that. Okay? And again, we can check it. Is -3 the answer? Put -3 back in here and see if it makes this true. Okay? Obviously, if this is incorrect and you solved it correctly, then you're going to have the wrong answer. So, hopefully you got to make sure this is correct. So you have the correct answer down here. All right, so let's take a look at 3 more examples. Turn my paper over here, just a second. All right, example number 2. When a number is decreased by 20% of itself, the result is 20. What is the number? Okay, well, we're looking for the number. So x equals the number. Okay, I look for the equal sign. The result is, that's my equal sign. Right side is pretty nice. The result is 20. On the right side of my equation is going to be the number 20. When a number is decreased by is subtraction. 20% of, the word of by itself means multiplication. Okay? 1/4 of a number is 1/4 times a number. So we're going to do 20% times itself, which is, of course, the number. Okay, so we've mapped out what the symbol is, the English to math. Let's write our equation. When a number, okay, x, is decreased by, there's no word than, so we're just going to do it left to right, 20% of itself. Okay, 20% times itself. The result is 20. And there is my translation. When a number is decreased by 20% of itself, 20% times itself, the result is 20. Now we know we're going to have to change our percent into its fraction form or its decimal form before we do math. So let's do that. 20% as a decimal is 0.20. And here is the equation that therefore now we can begin to solve. Simplify, we can simplify the left side. Now don't forget, there's a 1 here. An understood 1 in front of that x. Well, 1x minus 0.2 of an x leaves us with 0.8 or 0.80, either way, of an x. A whole minus 0.2 is 0.8. And now there's no separation. We're already separate. We just need to solve it. Divide this side by 0.8 or 0.80. Divide this side something divided by itself is 1, and x is equal to 20 divided by 0.80 is 25. Okay, let's think about it. We can kind of look at this one and think, okay, does this make sense? Is 25 decreased by 20% of 25 equal 20? It kind of makes sense. Obviously, if we start with a number that's like 25 and we decrease it by a fifth, 20% a fifth of itself, we can get pretty close. So that seems to make sense to me. All right, let's get into a couple of real-world examples. All right, including an 8% sales tax, a hotel charges $162 per night. Find the hotel's nightly cost before tax is added. All right, well, X equals hotels nightly cost, and we're obviously talking in dollars, before tax. Whoops, I lost the E on my word before. Before tax. That's what we're looking for. And we want to be thinking, the cost before tax better be less than $162 because that's the cost that includes the tax. So we should be thinking we need a number that's below 162. Okay, the nightly cost before tax is added is going to be less than the nightly cost after you add the tax on. And that takes place with anything you purchase that has tax. Okay, let's remind ourselves of a couple of things here. Okay, so let's talk about what we know here, because this one, in real world, including an 8% sales tax, there really aren't any, including it is kind of a plus, but there really aren't too many hints here as to translating the English into math easily, like we saw in this problem, which had, kind of nice words for us. Not quite the same with this problem. So what do we know? Well, we know that, I'll put down here 1 and 2, we know that the nightly cost plus the tax is equal to the total cost. Okay, so that's a given. That's knowledge we're aware of. Something costs money. We take that amount it costs. We add tax to it, and we get its total cost. Often, this is considered the subtotal. When we add up all these things, you add tax on, and you get the total. So we know that. You buy a pair of pants, you add cost, you get the total cost of the pants. You add tax, And we also know that tax is a percent of, in this case, the nightly cost, the item or the service being purchased. So those two things we had to know coming in, and we do know those things from our experience being consumers, being citizens, being purchasers, etc., etc. Having been out shopping using money, we know how this works. So, okay, nightly cost plus tax equals total cost. Tax is a percent of nightly cost. Let's do our equation. The nightly cost plus the tax. Well, the tax is 8% of the cost. I'll write 8% again as 8% times the cost. And we're going to come up with our total cost, which is $162. Okay, so it's kind of similar to problem 1 now that we've gotten to here with percents. We know we got to change this into its fraction or its decimal equivalent form in order to do any math with it. I'll put it into its decimal form. 8% is 8 over 100. It is 8 hundredths. And so here is the equation we're going to solve right here. As a reminder, now we're into our solve the equation. Simplify both sides. Right side is simple. Left side has 2x terms. They can be, in this case, added together. Don't forget, there's an understood 1 in front of that x. So 1x plus 8 hundredths of an x. And we have 1 and 8 hundredths of an x. And there we are. Okay, now can we separate? No, they're separated. X is in this case on left. number on right, that step's as necessary, and it's not necessary in this case. Let's solve. Divide both sides by 1.08, because 1.08 divided by 1.08 is 1, which gives us the 1x we're looking for. I've already used a calculator to do the math. 162 divided by 1.08 is $150. And again, does it make sense? Well, the nightly cost before tax is added better be less than 162. The tax is 8%, which is not a very large percentage, so we're off by $12 here. Not very different from 150 to 162. So the answer seems to me to make sense. Okay, last problem. And again, there's no way to do all these kind of things, but here's another example of what we're looking for, and we'll follow the same process. You're choosing between two health clubs. Club A offers a membership for a fee of $40 to join the club, and then you're going to get a monthly fee of $25. Club B says, hey, we only charge you $15 to join, but our monthly fee is $30, $5 higher than Club A. Okay, so different joining fees and different monthly fees. After how many months will the two clubs be the same? Okay, X equals number of months. That's what we're looking for. How many months? And we want the cost of the two clubs to be the same. So we want cost of A to equal cost of B. Okay, well, how do we find the cost? Okay, let's look at Club A. Okay, Club A. Cost equals. I'll put an arrow to like a minus sign. Club A, $40 plus, there's a positive, okay, monthly fee. You're doing the same thing over and over again. This monthly is telling me I'm going to multiply. Okay, so $40 plus $25 times the number of months. So 25 times X. That's the cost for Club A. Okay, 1 month, $40 plus 25. 2 months, $40 plus 50. Every month, the joining fee is just a one-shot deal. $25 occurs every month, hence the multiplication. Okay, how about Club B? Okay, Club B's cost, well, they start off with a joining fee of $15 plus, there's the plus, monthly is telling us we're going to multiply because it's going to take place every month, same thing. So to get the total cost for a month, you multiply, and it's going to be $30 per month, okay, for each month. So there is the cost of Club B. We want the cost of A to equal the cost of B, all right? So we're looking for 40 plus 25x to equal 15 plus 30 times x. Again, here's Club A, and here is Club B. There's our equation. Now we're off and solving. Both sides, step one, simplify. Well, this is as simple as it gets. Number term and variable term. Right side is as simple as it gets. Number term and variable term. We cannot simplify any further. Step two, separate. X's on one side, constants or numbers on the other. I always like to keep my x's positive. So I'm going to move my x's to the right because I have more of them over here. So I'll subtract 25 x's over to the right. That'll be a 0, which means I'm going to move the number to the left. So I'll subtract 15 from both sides. And I come up with, well, 40 minus 15, I believe, is 25. And 30 x's minus 25 x's is 5 x's. We're now separated. In this case, x terms on the right, number term on the left. Now let's solve. We want to get 1x to find the number of months. Divide both sides by 5 to get that out of the way. Okay, and x is equal to 25 divided by 5 months. Okay, so 5 months, the cost of the 2 clubs will be the same. There are other ways to do this one as well, but that's the algebraic way. So there you have it. A few examples in terms of what you're getting into. You know, the idea is always the same. We're always working kind of from this general set of steps. Okay, step 1 is where most people go astray immediately, so be very clear on what you're looking for. Step 3 is the hardest one. You know, to try to pull in prior knowledge, to pull in what you know about mathematical symbols and their English equivalents to come up with that appropriate equation.